Alright guys, so welcome back, and I had to cut that video because it was just getting too long and I knew it was not going to fit. So we talked about characteristics in the last video, like making a temperature change or making bubbles or having a precipitate or having a color change. Those are all characteristics. Well, now we're going to talk about the main types of reactions. Make sure that when you watch these videos that you go back to the notes because I can't replay someone else's videos that I use in their notes. The first one is a synthesis reaction. Well, synthesis means to make something. So we take two simple substances, like A and B here, react them together to get AB. Sodium plus chlorine gives you sodium chloride. Sodium's poisonous, chlorine's poisonous, and you react them together, you get salt, which is really good on most of our food. The next one there is a decomposition reaction. A decomposition reaction is a larger molecule breaking down into something simpler. So in this case, one of the real simple ones here, this is water. We're going to break it down by using electricity into hydrogen gas and oxygen. And you actually get twice as much hydrogen gas as you do oxygen because there's two atoms of hydrogen and only one molecule of oxygen produced. Single replacement reactions have an uncombined element. So here, iron plus copper sulfate, basically it kicks out the copper. You get iron sulfate. Down here, I've shown you this in class, this is potassium. When you add it to water, the potassium can actually kick out hydrogen out of the water, and when you see it catch on fire, it basically trades places with it. Literally, the potassium is stronger and kicks out some of the hydrogen. So they just trade places. This is where it used to be. But it all starts out with a single element. Now we have the double replacements. Now these are most of your larger types of reactions. So you have two different things trading places. The one that I wrote out here, this is magnesium carbonate reacted with hydrochloric acid, gives you magnesium chlorate with carbonic acid. So in this case, this trades places with the chlorine and the hydrogens. So you have two substances trade places. Then the last one is what we call a combustion reaction. Now, my boys tend to love this. My boys tend to like to mess around, build fires of things. I mean, I was a boy too. I used to be a Boy Scout. We used to go camping all the time. So combustion literally means to burn. So in this case, here's methane gas, main component of natural gas. When you react it with oxygen, it takes a spark, and you will actually get a flame. Like as you burn natural gas, you'll get carbon dioxide and water given off. Now, as we're doing these, you'll notice that there's a coefficient of 2. When we start talking about balancing equations, you got to make sure that there's the same number of every type of atom on each side of the equation. So the last of this first section is how do we change the rate of a reaction? To change the rate, we can make it faster or slower, and chemists are always trying to gauge the rate of reaction to control the products of the reaction. Sometimes you want it fast, sometimes you want to make it slow so you can control the quality of your product. One of the ways to control a rate of reaction is to control the concentration of the reactants. Basically, if you put a whole bunch of wood on the fire, you get a really big fire. You know, if you put a whole bunch of gas on the fire to get it started, I had a friend of mine back in the day, he always wanted to dump gas on the fire and then light it. I'm like, you're going to burn yourself. And he's like, nah, I got it. The more of the concentration, the more you will have that reaction go. Other ways, you can increase the surface area. When I was in the Boy Scouts, they taught us how to make kindling out of wood. You take and make little tiny pieces of the wood. That makes the wood burn quicker and start your fire faster. That's why we use paper so much. Paper, when it burns, has a huge surface area. The more surface area, the more place for the reaction to occur, and it burns very quickly. Now, a piece of paper does not last near as long as a piece of wood. That surface area causes it to burn so much faster. We can increase the temperature. If you heat it up, you can cause reactions to go faster. This happens really well with those glow sticks. You know, you always get them on 4th of July. If you take a glow stick and put it into a glass of warm water, it'll glow really, really bright because you're speeding up the reaction. It won't glow as long, but it'll glow really, really bright. At the same time, if you take that temperature of that glow stick and you put it in the freezer overnight, you can take it back out the next day and it'll still be glowing, because as you slow the temperature down of the reactants, you slow down the actual reaction and you can make them last a little longer. And then last but not least, we have catalysts. And catalyst is something that you put into a reaction that does not become part of the reaction but speeds it up. So there's different types of metal catalysts that we could use. But really, when it comes to like my forte is in biology, there's a ton of enzyme catalysts that can cause reactions to occur within your body. In fact, there's thousands and thousands of reactions going off every second in your body. Every single one of them is controlled by an enzyme catalyst. Well, ladies and gentlemen, I hope you have a chance to go back and watch the videos in the actual note packet. Make sure your notes are filled in, and make sure you get into that chapter 7.1. Like I said, I did break this video in two, so it's not so long, but I hope you guys had a great time. We're going to be showing some different types of reactions in class. Until next time, I'm Mr. Hescox. Be good, be safe. Have a great day.